times the bottom y cubed minus the derivative of the bottom, the derivative of y cubed. Now y is not variable, so careful. The derivative of y cubed is 3y squared times y prime, right? Times the top, which is negative x cubed. And everything over y cubed squared. And let's simplify. This is negative 3x squared y cubed minus with minus become plus 3 y squared y prime x cubed and all over y to the 6. Now we're going to replace the y prime by this fraction that you have before. So this is negative 3x squared y cubed plus 3y squared, and y prime is negative x cubed over y cubed, and then times x cubed all over y to the 6, and then of course simplify. Right in here, y double prime is negative 3x squared y cubed. What can I simplify in here? The x cubed with x cubed gonna be x to the 6 with the 3 in front negative, so negative 3x to the 6 and over y, because y squared cancel out, take out 2 on the bottom, still got y left, and then y to the 6. Okay, you can simplify more actually. This is what? Negative 3x squared over y cubed minus 3x to the 6 over y to the 7. That'll be the final answer. Okay, so actually just more work, but the same idea. You want to calculate second derivative, we start with the first derivative and then move on to the second derivative. Let me double check on my work, see if I miss anything or if I got anything wrong in here. Yeah, looks right. Okay, let's try one more example. The implicits. Then we can talk about something else in here. Let's find an example in the book. Okay, I see this. X to the 4 plus x squared y squared plus y cubed equal to 5. Doesn't matter. Okay, it's a number. Now let's calculate derivative. First of all, take the derivative both sides. Another example. X to the 4 derivative is 4x cubed. The middle term I got product of two factors, x squared and y squared. So I have to use the product rules in here. Plus, product rules say what? Derivative of the first times the second, so 2x times y squared plus derivative of the second times the first. Derivative of y squared is 2y times y prime, because y is not our variable. Okay, y is a function. Think of it that way. So 2y y prime times x squared. This is derivative of y squared times the first, and plus y cubed. Derivative is 3y squared and then times y prime. Alright, same reason, equal to 0, because the derivative of 5 constant equal to 0. Now let's simplify. I got 4x cubed plus 2x y squared plus 2y y prime x squared plus 3y squared y prime equal to 0. I can group the y prime together in here. I got 2y x squared plus 3y squared. And then I can move the term without the y prime to the right hand side equal to negative 4x cubed minus 2xy squared. Now I'm going to divide both sides by whatever I got in parentheses. I got y prime is equal to negative 4x cubed minus 2x y squared all over 2y x squared plus 3y squared. Okay? And of course, if you want to calculate y double prime, you have to use the product rules in here and repeat it. It's going to be pretty long, so it's just y prime, and the book actually just asks you for y prime, and that'll be good enough. Okay, that is another example. Now, I see that at the end of section 3.5, the book gives you more formulas about derivative in terms of inverse trig function. So let me just put it up here for you. Okay, let's copy it from the book. Sine inverse of x derivative, because sine inverse is the same thing as arc sine, okay? Arc sine of x derivative is the same thing, equal to 1 over square root of 1 minus x squared. Okay, and then cosine inverse, let me just write either one of those two. Let me choose, how about arc sine instead of sine inverse. So arc cosine of x derivative, again, arc cosine, the same thing as cosine inverse, okay, is equal to negative 1 over square root of 1 minus x squared. Move on. Tangent inverse. Arc tangent. I keep writing arc tangent, right? So arc tangent. Derivative is 1 over 1 plus x squared. Arc cotangent of x. Derivative is negative 1 over 1 plus x squared. Well, let me double check, make sure that I got it right. Yes. And then secant, arc secant of x. Derivative is 1 over x times square root. Let me see. Secant is x squared minus 1. Yep. And then arc cosecant of x. Derivative is equal to negative 1 over x square root of x squared minus 1. You guys see the rules right here that help you to remember all of them. And whenever you have something with coordinates like cosine, cotangent, and cosecant, you have a negative in front. Okay, so sine inverse, arc sine derivative is 1 over square root. So arc cosine is negative 1 over square root. Arc tangent is 1 over 1 plus x squared. So arc cotangent is negative 1 over 1 plus x squared. So secant is 1 over x square root. And then arc cosecant is negative 1 over x square root, x squared minus 1. And as you see, I don't remember all the formulas. Okay? The problem is we don't need to remember. In here, last minute of this section, I will show you how to derive the formula, which is way more important than memorizing all the formulas, especially when you deal with the inverse trig function. So let me show you. Let me just do one, and then you can figure out the others. Okay? So we have sine inverse of x and take derivative, assuming you don't know. Of course, we know the answer is 1 over square root of 1 minus x squared, right? Say we don't know. We are looking for the answer. How do we figure it out? We let y equal to sine inverse of x, and our job is to find y prime, right? Derivative of sine inverse. And by the way, sine inverse right here is the same thing as arc sine. Okay, whenever you guys deal with the inverse function, most of the time you try to bring back to our normal function. So if y equal to sine inverse of x, that means x equal to sine y. See, input is x, output is y, the inverse input is y, output is x. Okay, now we're going to take the derivative of this normal function, the sine function. The derivative of x is 1. equal to derivative of sine is cosine of y. Again, we're going to use the chain rules in here. Implicit differentiation, y is not the variable, so don't forget to multiply by y prime. Okay, so divide both sides by cosine of y, you got what? Y prime is equal to 1 over cosine of y. Alright, now how to figure out cosine of y. Back to our trick. Okay, I got x equal to sine y, right? So y is the angle. And if I draw the right triangle, and this angle is y, you know that sine of the angle is opposite over hypotenuse, okay? And that's going to be equal to x. So think of x as x over 1. So what? Sine is opposite over hypotenuse. So if I write this is f, it's going to be 1. So I got sine of y equal to x over 1, which is x. Okay, that's the formula right here. So I'm going to calculate cosine of y. I'm going to calculate the other side. This is 1, this is x. Pythagorean theorem tells me that this one is going to be square root of 1 minus x squared. Okay? Because what? X squared plus this 1 minus x squared equals to 1. In other words, I take 1 squared minus x squared and then take square root. I got this. So cosine of y is adjacent over hypotenuse. It's going to be square root of 1 minus x squared over 1, which is just square root of 1 minus x squared. And I'll plug it in here. Y prime is 1 over cosine, which is 1 over square root of 1 minus x squared. I got the formula. Okay? You guys apply the same method to cosine inverse, tangent inverse, cotangent inverse. You should have the answer. And I think that 2 examples is always better than 1. So instead of stopping right here, let me just give you one more about sine and how about tangent. Okay? Because cosine is very similar to sine. And you guys can figure out the rest. Hopefully, one more example will help you. Tangent inverse of x. Derivative. What is that equal to? Of course, we know the answer ahead of time because I gave you the formula, which is 1 over 1 plus x squared, right? Or x squared plus 1, the same thing. Okay, we're going to get there. Same strategy, same idea. I'll let y equal to tangent inverse of x. So, bring it back to our normal trig function. X equal to tangent of y. Now differentiate both sides. 1 is equal to, the derivative of tangent is secant square of y and then times y prime. Okay? Or secant square is 1 over cosine square of y, just in case we need it, times y prime. Okay? So really y prime, multiply both sides by cosine squares. Y prime is multiply by cosine squares, or cosine square y. Okay, now let's figure out what is cosine of y equal to. I got x equal to tangent of y. We're going to go back to our favorite right triangle again, and y is the angle. And I know the tangent is opposite over adjacent. So this is x, this is 1, so I got tangent of y is equal to x over 1, which is x, right? That's what we have right here. This is 1, this is x. Pythagorean theorem say that this side is going to be square root of 1 plus x squared. Okay, 1 squared plus x squared, x square root. Okay? Now I want to calculate cosine of y, because the formula involving cosine. Cosine of y is adjacent over hypotenuse, so cosine of y is 1 over square root of 1 plus x squared. So cosine square of y, gonna be square up the whole thing, square root of 1 plus x squared, everything square up, which is 1 over 1 plus x squared. And this is y prime. So y prime is equal to cosine square of y, which is 1 over 1 plus x squared. And that's how you have the formula tangent is equal to 1 over 1 plus x squared. And I claim that you guys can apply the exact same step that I have. I show you in the 2 examples to calculate the other inverse function. Okay? Hopefully those materials and the example that I'm giving you in this clip is going to be helpful for your learning. Thank you very much for watching and have a good day.